Bismillahirrahmanirrahim. We will continue our discussion on the basic concepts. In our last lecture, we had talked about the system, models. We had done some discussion on the models, and then we had discussed types of models: physical model, symbolic model, mental model. And we had extended discussion on these different types of models. Then we had discussed symbolic models, and in symbolic models we discussed that there are two types: mathematical models and non-mathematical models. So our interest is actually mathematical models, this type. Okay. And in mathematical model, we had already talked about the dynamic model and static models. These both are the types of mathematical models. We had discussed mental models. Similarly, we had talked about the deterministic model, stochastic models, linear model, non-linear models. Although we will do some detailed discussion on these different types in our future lectures. Now we will discuss in today's lecture. We will talk about mathematical modeling. Okay, so it creates a mathematical representation of some phenomena to better understand it. Okay, in our last lecture we had discussed about systems. So in mathematical modeling we try to represent that system or that natural phenomena through mathematical symbols, mathematical formulas, etc. So this is the actual concept of the mathematical modeling. And in mathematical modeling we try to match observation with symbolic representations. Okay, so let's say in natural phenomena we are considering a system, and then in that system we will be having some output or some observation. So those are represented through some symbolic representation, and it informs theory and explanation. The success of mathematical model depends on how easily it can be used and how accurately it predicts. We are mostly interested in accurate prediction, although there are some other areas for which we use models, but usually this is used for prediction and how well it explains the phenomena being studied. So when we represent a natural phenomena through a model, then the next step is that how it explains the observations or the outcome. Okay, so a mathematical model is central to most computational scientific research. Uh, Other terms that are used in connection with mathematical modeling are computer modeling, computer simulation, computational mathematics, scientific computation, and so on. So, in computer science, we use the computer simulation for simulating the different systems. For example, let's say in natural phenomena, we can consider the human system, and in human there are many systems, but let's say we consider the walking phenomena. So in this simulation we try to to map the human and some computer model, and then the walking style is simulated. So this human as well as the different actions, the different moments that a body perform, so these are represented in this model, and then in this simulation the model can work, or it can perform different tasks. So in this model, we try to model or to simulate as accurately the human behavior of working as possible. Okay. Uh, so usually in computer science, the most important area where mathematical modeling is simulation. Okay, now why do we use models? So, fundamental and quantitative way to understand and analyze complex system and phenomena. So, for this understanding, we used models, and it complement to theory and experiments, and often integrate them. So, there are many areas where it is usually difficult to do practical experiments. Then, in that case, we can use computer simulations for understanding the phenomena. Okay. And it is becoming widespread in computational physics, chemistry, mechanics, materials biology, etc. Okay. So usually in these different areas, instead of practical experiments, are sometimes an experiment, it takes a long time. Some experiments can take years. So in order to have some alternate mechanism for performing those experiments, we do computer simulation. We try just to copy those experiments, to model those experiments, and to do simulation on computer. So for these, the mathematical modeling or computer simulation are important. Now, mathematical modeling is actually a combination of mathematics, computer science, and then there will be some application area from the science. So this is the fusion of these three different subjects: mathematics, computer science, and then the science will be some application area. Okay. So, mathematical modeling seeks to gain an understanding of science through the use of mathematical models on computer. This is very interesting definition. Understanding of science through the use of mathematical models on computer. So, science is an application area, and mathematical models are the mathematics, or the behavior, how the phenomena works, and then we try to copy that phenomena on computers. Okay. uh, it complements but doesn't replace theory and experimentation in scientific research, as I already discussed that we can perform experiments to do how the system works, but sometimes experiments are difficult to perform. So for that, we use mathematical models as alternate of that those experiments, and then we try to simulate the experiments on the computer. So these simulations are some alternate way of what outcome we expecting from the experiment. So usually the simulation can give us those outcomes. Okay, now mathematical modeling is often used in place of experiment when experiments are too large, too expensive, too dangerous, or too time consuming. And this is the process. So let's say we have a real world problem, then we simplify that real world problem into a workable model, and then that workable model is represented through some mathematical models, and then that mathematical model is converted into a computational model. A computational model can be simulation framework or any other thing, and then after performing that simulation, we can get results or conclusion. So this flow can also be obtained through practical experiments, but as I already said that sometimes practical experiments are too time consuming or too expensive, so simulation is an alternate way to get those the outcome of those uh, practical experiments can be achieved through these simulation. Okay, so thank you, and we will have further detailed discussion in our next lecture. Thank you.